Okay, so here we go for this week. Today we're going to be looking at some different types of plate boundaries. Last week we looked at divergent boundaries, so today we're going to knock out some of the other ones. So looking at this diagram, you can see plate boundaries come in three types. There are when plates pull apart, which last week we learned was divergent boundaries. And as they pull apart, it's usually underwater. And as they pull apart, magma comes up, fills the gap, creates new ocean floor, and that has that whole process of seafloor spreading going on. It's got the mid-ocean ridge with the Rift Valley in the middle of it, so hopefully that rings a bell. When plates come together, they're called convergent, and when they grind past each other, it's called a transform boundary. Now, I'll mention this again at the end, but really all we need to know about transform boundaries is the plates are grinding past each other, and it leads to earthquakes. No mountains, no trenches, no magma, just earthquakes. Now, on a side note, every plate boundary is going to give you earthquakes because every plate boundary creates stress. I'm just writing earthquakes because that's the only thing that happens at a transform boundary. I could write it for every single one of these, and I guess I could just to remind you that they happen at every plate boundary. Okay, let's go back to convergent boundaries because this is really where we're going to spend our time today. When two plates come together, it's called convergent because they converge. Now there's different types of crust. There's oceanic crust, and there is continental crust. So I'm using an O and a C for oceanic and continental here. So when it's an ocean plate meeting an ocean plate, or an ocean plate running into a continental plate, we have what's called subduction, which is where one plate subducts or goes underneath the other one. And it's always the one that is more dense. The less dense plate is always the overriding plate, the one that stays on top. So again, when these plates meet, it's a subduction boundary, and the more dense plate gets shoved underneath and sinks or subducts. When it's two continental plates, they have the same density, and so they both get shoved upwards to form mountains. No volcanoes, no trenches, nothing fancy, just mountains. So that's about all there is to say about collision boundaries. So subduction boundaries have a lot more depth to them. So let's go ahead and talk about them for a little while, and then I'll wrap up mentioning these one more time. So if you want to grab your notes for subduction boundaries, we will get rolling here. So you should have a sheet that looks something like this, or be taking notes on your own sheet of paper if you want. So for starters, again, subduction is where one plate subducts under the other one because it is more dense. The less dense plate is the overriding plate and stays on top. That's just what subduction means. Now, when one plate subducts under the other one, we get some features, namely trenches, folded mountains, and volcanoes. So we're going to start here in the middle and look at a side view of this, then we'll go back and relate it to this map up here. So for starters, this map is taken off the coast of Washington, kind of like in a line right here, give or take. So, side view, you've got Pacific Ocean, you have Washington State. This is an ocean plate, obviously, it's under the ocean, and this is a continental plate, and they are colliding. Why are they colliding? Because the convection currents are bringing them together. And where they collide, the ocean plate is more dense, the continental plate is less dense. So the more dense plate is going to get forced down, but as it does, they're like running into each other. And so this more dense plate drags the less dense plate with it and creates this really deep trench on the ocean floor. Okay, that trench marks the site of subduction. So what we usually say is that right there is the subduction boundary. So like this green line up here, I'm going to tell you is a subduction boundary. That means that green line is a trench. Okay, that happens right on the boundary line. So now as this plate goes down, a couple of curious things happen. Number one, if I were to cram my hand underneath this paper, guess what? The paper is going to get lifted up, right? So as this plate gets shoved underneath the continent gets pushed up. Now at the same time, picture a head-on collision, okay? Whichever vehicle has weaker metal or is less dense is going to get crinkled up, right? So the land not only gets shoved up, it also gets crinkled up into mountains. In this case, those mountains are called the Rocky Mountains. So as this plate, which by the way, it's called the Juan de Fuca plate, that name should ring a bell. As the Juan de Fuca plate subducts, it shoves the land up and crinkles it to form mountains. Now the other curious thing is this. As it goes down, it takes water with it, because you got to realize this plate is saturated with water. It's in all the pore spaces of the rocks. So as it goes down, it takes these little bits of water with it, and the water leaches out a little bit into this continental crust, which is less dense, which means it melts easier. Now, there's this odd thing that happens. When you put water in rock, it actually makes it so the rock melts easier. It's kind of like when you add salt to ice. It'll make that ice melt even though it's below freezing outside. It makes it so the molecules, the actual crystals themselves, can't bind to each other. So the water right here in this less dense rock makes it so the minerals in the rock can't bind to each other, and it breaks them free, which means it's going from a solid to a liquid. And so what you have down here is, instead of solid rock, you start to get a pool of magma. And it's all because this water comes down with the subducting plate and leaches into the continental crust. So now that I have magma, magma by its nature is less dense than solid rock, and so the magma is going to try and work its way up, and it's going to give us a volcano. So now let's look at this map up here and see if we can relate it to this. You have the Juan de Fuca plate subducting underneath the North American plate, right here at the green line. So that green line is a trench. So I'm just going to put a couple of T's on here. T, T, T for trench. Okay. As it goes down, what's it take with it? Water. And as the water goes down with it, deeper and deeper and deeper, it helps form magma. And all these red dots that I added are volcanoes. And those are called the Cascade volcanoes. There's a line of them that starts in Washington and runs down into Northern California. Now you'll notice the volcanoes stop right about here, right about where California bends. See where I'm pointing? That's because the subduction boundary stops right here, and this becomes a transform boundary. So if you remember from the intro, I don't get volcanoes here, I don't get mountains here, all I get is earthquakes. So we'll talk about him at the end, but we don't have volcanoes down here because there's no subduction. So back up here, Juan de Fuca plate, subducting under the North American plate, forms a trench, just like this, takes water with it, which forms magma and gives me volcanoes, and it shoves the land up and wrinkles it to form these rocky mountains. Okay, so hopefully you can see a connection between these two pictures. Hopefully you take a few minutes to jot down some thoughts on how these form and why they form at ocean to continent subduction boundaries. Down here, definition of subduction once again is when the more dense plate gets shoved under the less dense plate. And I wrote earthquakes just to remind us that earthquakes happen when? Anytime there's stress. Where do they happen? All plate boundaries. That's a terrible abbreviation. Let's try again. Boundaries. I don't know if that's any better, but we'll go with it. Okay, so there's the first page. Feel free to pause and rewind, jot down some good notes. And when you're ready to go, we'll go on to page 2. Now, page 2 is what happens when an ocean plate runs into an ocean plate. Because now back on page 1, we had ocean running into continental, and ocean is more dense than continental. What happens when it's two ocean plates that are running into each other? Now, if you remember back to divergent boundaries, when plates are pulling apart, the farther away they get from the mid-ocean ridge, the colder and more dense they get. So as a result, these guys will have slightly different densities. Now in this case, I can see this is the plate going down, so he must be slightly more dense, he must be slightly less dense. Now this is going to sound familiar. As the more dense plate goes down, it drags this plate down a little bit because of the friction and forms a trench, sometimes called a deep sea trench because it's deep in the sea, go figure. As it goes down, you know what it takes with it? Yep, it's taking water with it. As that water gets down here into the less dense crust, what does it start to form? A pool of magma. Now magma is less dense, so what's the magma going to do? It's going to rise and it's going to form a volcano, and if that volcano gets big enough, it sticks up out of the ocean, and we would call it a volcanic island. Now, typically, an ocean-to-ocean subduction boundary is going to form volcanic islands in a curving pattern, and we usually call that an island arc or a volcanic island arc. A good example of that down here is in Alaska. Now, Alaska has this chain of islands coming off the end of it in a nice curving line. They're called the Aleutian Islands, and every one of them is a volcano. That's because right down here where I'm drawing this line, there is a subduction boundary. You have the Pacific Plate moving this way. You have the North American Plate moving this way, which creates a subduction boundary, ocean to ocean. So along this line, you're going to have a trench, and you're going to have a bunch of volcanic islands. Let me grab my red pen, and we'll just go. There we go. We got some volcanoes. Now, just to review from the first page, here I've got ocean meeting continent. So I'm still going to have a trench, but on land, I'm going to have volcanoes. And then behind the volcanoes, I'm going to have a bunch of mountains. So in Alaska, you have two types of subduction boundaries, ocean to ocean and ocean to continent. And you can see what happens with both of them. So that, in a nutshell, is what happens when you have two plates run into each other that have different densities. Last but not least, just to wrap all this up, transform boundary is when two plates grind past each other. A good example of that is the San Andreas Fault, and that is in California. You can go back to the map if you need to see it. And a reminder, you get earthquakes there, but there's no mountains, there's no volcanoes, there's no trenches, no rift valleys, nothing. Just earthquakes. And last but not least, quick review. Collision boundary is when you have a continental plate run into a continental plate, and they both get forced up. It gives you mountains, but no volcano because there's no subduction. If there's no subduction, there's no water going down, there's no melting of rocks, and you're left with just mountains. So that wraps up our plate boundaries, and that wraps up pretty much everything for this first chapter. So be sure to look over the study guide, go through it, add notes to it. The test will be written right from that study guide, so please make sure you look at it, use it to study, because it will help you immensely. If you have any questions, please make sure you email me or tell me on Google Classroom, and I'll be glad to get back with you. Talk to you later.